So we've already talked a little bit about atoms and a little bit about matter, and today we're going to dig in more with it. So our goals for today are to really dig into this: what is matter and what is matter made of, to get us really more into this matter and its interactions unit. So just kind of a little thought experiment here you're going to do for your warm-up. What would we have if we chopped an apple in half? So let's have an apple and I chop it in half down the middle. And then what if I chop that half in half? And I chop that half in half. And so I keep going into smaller and smaller and smaller pieces. How far could we go with it still being an apple? So I want you to think about that. You've got a discussion post on Carmen. Just, kind of like, how many times do you think you could chop it in half before it stops being an apple? And when it stops being an apple, like, what does it become then, right? So what do we get if we keep chopping it in half and half and half and half over and over again? And so how small could we go, and does it ever stop just being parts of an apple? So there's your warm-up question. So think about that, and then you can come back to this video once you have answered that question. All right, so whatever your answer was, let's kind of talk about it from a more scientific perspective. So what is an apple made of? And a scientific answer might be that we have many different molecules organized and combined in a particular way. And so then the question is, well, what is a molecule? And so a molecule is a particular combination and arrangement of atoms. And so here's an example of a molecule here. So we've got a sucrose molecule. Sucrose is one type of sugar. There's a bunch of different types of sugar. And we can see this is kind of what a sucrose molecule looks like. Now, before we go any further, you also have this sheet that you've been working on, or that you're going to start working on. And so we have our answer for our first question. It says, what is a molecule? It's a particular combination and arrangement of atoms. So over here, you can click in here and type in a particular, what did I say? A particular combination and arrangement of atoms. So a particular combination and arrangement of atoms. Okay, so then let's go on to our next slide. And the question is, well, what are atoms? And so you might have a little bit better idea of that because we've read about it a little bit, and I'm sure you've learned about it before. So atoms are the building blocks of the universe. They are just, the smallest example of one element that you can have, and they cannot be broken down into other elements. And so some examples that you have probably heard of that are relevant to my example here, this sugar molecule. So I have hydrogen. Those are all of the kind of white or gray little circles here. Can't see that very well because the little thing's in the way. Carbon are all of the black ones. All these black ones in here are carbon. And then the red ones are oxygen. Okay, so this is going to help us answer our next question. It says, what are atoms? I can say over here, atoms are the smallest building blocks of the universe, smallest sample of an element, something like that. I'm not even using complete sentences. We just want to kind of get the main idea down, right? Okay, so there's my definition of an atom for you. If you need to pause it, you can go ahead, but I'm going to keep moving on here. So go back to my slideshow. Okay, so we already went through all that. Atoms. Okay, now next up. So we said they're the smallest building block of the universe, but as it turns out, we can actually go smaller. And so you really can't trust atoms because they make up everything. So that's my terrible joke for the day. You can't trust atoms because they make everything up. Like they just make it up as they go, right? Okay, so it's a dumb joke. I don't know why I put it in there. Okay, so what are atoms made of? So that was what I was going to start talking about next, right? So atoms, as it turns out, are not the smallest thing because atoms can actually be broken down into smaller parts. And so what can we break them into? And so there's three things that we are going to worry about here. We've got protons, we've got neutrons, and we've got electrons. And you maybe have heard of some of those before. And the main ways that we are going to keep track of protons, neutrons, and electrons is by their charge, their mass, and their location, or where they are. Okay, so charge is basically, you can think of that as kind of like electricity. And so it can either be plus or positive, or it can be minus or negative. And so protons have a charge of +1. Neutrons have no charge, so that's why they're called neutrons, because they are neutral, so they're kind of in the middle. And then electrons are negative. So my best advice for remembering that is protons are positive, so protons have a plus, so it's, the P there. Neutrons are neutral. Now that gets a little bit confusing because people want to think, oh, neutron starts with an N, negative starts with an N. Neutrons are not negative. So that's just a tricky thing that you got to keep track of. And then electrons are negative. That's the one that's left over. Okay, mass is a little bit easier to think about. Mass is just kind of like how much, how heavy they are. We could kind of think of it like that. And we're going to measure this with a special unit called an AMU, and that stands for Atomic Mass Unit. And so the mass of a proton is just 1. So we chose this to make it pretty easy to keep track of, right? So a proton has a mass of 1. A neutron also has a mass of 1. So they're about the same size and the same weight. Now, electrons are so much smaller even than protons that they have almost no mass. And so we kind of round down to 0 because it's so small compared to a proton and a neutron. And then the last thing is, like, where do we find it? And so maybe you know what a nucleus is. Maybe you're thinking about cells. Maybe you have no idea what I'm talking about. We're going to get to that in a second, okay? So protons and neutrons, we can find them in the nucleus, and electrons are in the orbitals. And so before I explain what all that means, we're going to use that to fill in the next little table on our worksheet. So we're going to come back over here. Okay, so protons, I said they're now be careful here. So I almost confused myself. Whenever you have to fill in one of these tables that I give you, make sure you're keeping track of which column you're in. So proton, I said the mass was 1. And for neutron, the mass is also 1. For the electron, the mass is 0. Okay, now let's go to charge. So the charge of a proton is +1 or +1. So like I said, the P there is, you can help use that to remind yourself. The charge of a neutron is neutral, so that is 0. And the charge of an electron, okay, they were like hammering on something in the hallway. Sorry about that. So the charge of an electron is -1. -1. There we go. Sorry. Okay, last of all, let's talk about location. So we can find protons in the nucleus. We can find neutrons in the nucleus. So you can think about, the things that are heavy, the things that have mass, are both going to be in the nucleus. And then the electrons we are going to find in orbitals. Okay, so now let's figure out what the heck all of that means. So let's go back to our slideshow here. And moving on here. Okay, so here's kind of the anatomy of an atom, so the different parts. So you might remember that I told you protons are in the nucleus, neutrons are in the nucleus, and electrons are in our orbital shells. So what I mean by that is my protons, the plus ones here, they are in the middle, and the neutrons are also there, stuck to them in the middle, and then orbital shells are going to be around the outside, okay? So you might think of this as like the nucleus is the part in the very center. That's kind of what nucleus means, is in the center of something. And then the electrons are more around the outside. And so my electrons might be kind of all around there. And so even though I'm going to say like this atom here that I have has 2 electrons, and so, they're kind of on that outer shell, they are zooming around like crazy. They're going all over the place. And so what actually is maybe a better way to think about it is that we have a little bit of minus, a little bit of negative spread all over that whole shell, okay? And we'll, this kind of might tie in with some of the ideas that we were looking at last week with different models of the atom. So anyways, that's kind of the basics there. And I think this will help us do the next thing in our worksheet. So what you need to do We've kind of done something similar to this before, but you're going to click on the picture, and then you're going to go to edit. Now, what I want you to do is you're going to make a text box on each of these little lines to say what it's pointing to. Okay, so to make a text box, you click this little T that says text box, and then I'm just going to click over here. And so this top line is going to the plus ones, which is the proton. And now this box is kind of too big, so I'm going to move it over here. And if I just use the up arrows, I can move it around. So I'll put it kind of right there, or you can drag it around with the mouse if you want. It doesn't really matter. Okay, so now I'm going to do same thing. So make another text box. And actually a little trick too is if you want to just drag to the shape and area you want your text box to be, you can skip that moving it around stuff. And so this arrow is pointing to the blue circle that doesn't have anything, which I told you earlier was the neutron. And then, of course, the last thing would be this minus thing down here. And so I will label that the electron. So one other point on this diagram that I just was thinking about that maybe I should clear up. This is supposed to show you kind of like if you could zoom in really close, you would see the electrons are tiny and they're zooming around on the outside. So they are flying all around here. And so like atoms are tiny, right? Protons and neutrons are even tinier, and electrons are even tinier than that. And so that will get us to something we're going to talk about here in a second. But I just wanted to kind of make that point that that's what this diagram is showing, that those electrons are so tiny down there that you wouldn't even be able to see them, but they're zooming around like crazy. Okay, so save and close that. And look, now our picture is updated, except mine got kind of squished a little bit for some reason, so I'm just going to drag it over so that it looks a little bit more circular there. Okay, so like I said, we were just talking about size of this stuff. So let's go and look at our next slide. So how big is all this stuff? So I'm not 2 meters tall. 2 meters tall, I'm shorter than 2 meters. I'm maybe like 1.6 meters or something like that. But, just for the sake of our comparison here, we'll round that up to 2 meters. So I'm about 2 meters tall. My thumb is about 0.02 meters tall. The width of a human hair is about 0.0002 meters tall. So that's like very small, right? Or meters wide, I should say. A red blood cell is 0.000002 meters tall. So tiny, even that's like a 1% the width of your hair. A helium atom is, all right, get ready, 0.00000002 meters. I think I got them all in there. But the point is that it is now 1,000. You need to line up 1,000 helium atoms. I think 1,000. Let me see here. So that would be 1, 10, 100, 1,000, 10,000 helium atoms side by side just to make one red blood cell. And we're not even to the bottom yet, right? So I'm going to have to move my little picture here, I think. So I'll slide myself over to here. There we go. And then, so a proton is now, I'm not even going to read all the zeros, but you see it's even smaller. Maybe you need 1,000 protons lined up side by side to get a helium atom. And then last of all, we have an electron. So that is I'm not even going to read it. It's really small, right? So now you need another 10,000 or whatever electrons lined up side by side to make a proton. So then if you compare like the size of a person, 1 or 2 meters tall, to the size of an electron with that 0.00000000002 meters, you can tell that electrons are really freaking small, right? Okay, so now what we're going to do, we're going to have to flip back and forth here a little bit, but it might be easier with me telling you here. But on our next little bit here, we are going to, so this is number 5, number 4 was labeling the atom. We're going to use some powers of 10. I'm going to squish this just a little bit so that, there we go. Okay, so I was about 2 meters tall, so that would be 10 to the, remember exponent, you do control and then the period button, or control and the greater than symbol, the one right next to the question mark, that would be 10 to the 0 power, right? Because that's 1. So it's like on the scale of 1 meter or 2 meters. That's like kind of the same ballpark. All right, width of the thumb was 0.02. So if I did 10 to what exponent would be 0.02? Why don't I make this a little bit bigger so that we can see what's going on here a little bit better. Okay, so that would be 10 exponent is control and period -2, right? Because I had to move the decimal over 2 spots. So hopefully that's review for you by now. For this one, it would be I have to move the decimal 1, 2, 3, 4 spots. So human hair would be 10 to the -4th. Red blood cell, all right, 1, 2, 3, 4, 5, 6, 10 to the -6 meters, kind of in that ballpark. All right, now here's where things start getting fun. Helium atom. This is where it's going to be hard to count, so I'll count it out for you again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 meters. So 10 to the -10. Scroll down a little bit. Proton is going to be, all right, buckle your seatbelts. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 10 to the -14. 10 to the -14 meters. And the last one, all right, we're going to have to do a lot of counting here. So we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 meters. So that, oops, what did I do? I don't even know what I did. Okay, there we go. That is really, really small, right? 10 to the what did I say? 19. I hope I said 19. Whatever I said. Or you can go back and count. I won't go back and count in the interest of time. So 10 to the -19 meters. That is tiny, right? So let's move on to the next exciting thing we've got going on here. So we did this whole thing. There we go. So let's talk some numbers here. And I'm going to move myself, try to move myself up to the top here. There we go. Okay, so numbers and atoms. So here's some important numbers that we're going to talk about. Atomic number is the number of protons an atom has. Okay, so it's easy as that. However many protons it is, that's the atomic number. You got 12 protons, 12 is your atomic number. You got 18 protons, 18 is your atomic number. You got 119 protons, 119 is your atomic number. Okay, so that's pretty easy. Mass number is a little bit harder, although it's still not that hard, right? So mass number is going to be the number of protons plus the number of neutrons. So the way you can think about that is if you go back to our little table we made earlier, protons have a mass of 1, neutrons have a mass of 1, neutrons also have a mass of 1. Electrons have a mass of 0, right? No mass. And so we're going to add up all the things that have mass, and that is our mass number. And so if I have 2 protons and 2 neutrons, mass number is 4. If I have 8 protons and 10 neutrons, mass number is 18. Okay? Good. Okay, so then last of all is, still not that bad, and that's going to be charge. So to find the charge, you take the number of protons and you subtract the number of electrons. And so think about, protons have a plus charge and electrons have a minus charge. So you could think about it as adding up all the protons and subtracting the number of electrons, because protons are plus charges or positive, and electrons are negative or minus charges. So we can now hit the right button to get out of our slideshow, come back over to our worksheet, and type in our definition here. So we just said the atomic number is the number of protons in an atom. Okay, Now, Mr. Schober made a mistake here, so we're going to fix this. This should not say atomic mass. This should say mass number. So yours will be fixed. I just had to fix that on mine. Atomic mass is something that's a little bit different. We'll worry about that later. For right now, though, we said mass number is the number of protons plus, or if you want to use the plus sign, you can do that, plus the number of neutrons. Okay. Now, last of all, charge is the number of protons minus, or you can use the minus sign, the number of electrons. There we go. Okay, so let's go back to our slideshow, and I'm not sure why there we go. Let's come back over here. Okay, and let's go back in. Oops. Okay, so we're going to do some practice here. And I'm going to get myself, I don't know where I'm going to be most out of the way. I'll move my picture in a minute. Okay, so what I want you to do is think about everything we just learned. So I drew a little picture of an atom down there. That is going to be a lithium atom, actually. And we'll talk about how to know what atom it is in just a little bit, or maybe tomorrow or some other time soon. But what I want you to do is I want you to look and see how many protons does this atom have. And that is your atomic number. So it should be 3, right? We have 3 protons. We have this little plus guy here, this little plus guy back there, and this little plus guy right there. So that's 3 protons. So atomic number is 3. All right, what is our mass number? So remember, for mass number, we want to add up protons. So I have 3 of those, already counted that, plus how many neutrons? Well, I got 1, 2, 3 of those. So that's going to be 6 neutrons altogether. Okay, last of all, charge. We're going to do protons minus electrons. So what's the charge for this lithium atom? Okay, so again, protons, I have 3. Electrons, I also have 3. 3 minus 3 is 0. So my charge would be 0 for this one. Let's try another one. So here's helium. How many protons does it have? So what's the atomic number? So that should be 2, because I have 2 protons. 2 protons means the atomic number is 2. Mass number, I'm going to add protons and neutrons, and that's 4, right? I have 2 protons here, 1, 2, 2 neutrons, another 2 right there. 2 plus 2 is 4. All right, and what about the charge? Protons minus electrons. All right, so when you do protons minus electrons, you still have 2 protons. We got 2 electrons floating around there. So 2 minus 2 is 0 again, right? Okay, good job. Let's do another one here. We got boron. So what is the atomic number for this boron atom? And we got 4 protons, so that would be 4. What is the mass number for this boron atom? Well, we already said I have 4 protons. I also got 4 neutrons, so that mass number is 8. And for charge, still got 4 protons. Count out 4 electrons, so 4 minus 4 is 0. Okay, so this one you don't have to count, because when I was making the pictures, I was like, this is a lot of counting, and the bigger the atoms get, the harder it is to count. So I just told you the number of protons, neutrons, and electrons. So based on that information, what's my atomic number? 6 protons means the atomic number is 6. What is our mass number? So 6 protons, 6 neutrons, add them together, and I get 12 for my mass number. And for charge, I would take 6 protons minus 6 electrons, and I got 0 again. So we've seen a lot of charge equals 0. That's going to be the case a lot of the times, but not all the times, as we'll see in a little bit. All right, another one here. So nitrogen has 7 protons, 6 neutrons, and 7 electrons. What's the atomic number? 7, right? Count the protons. Mass number, 13. Protons plus neutrons. And the charge, 0 again, right? Okay, 7 minus 7 is 0. And if we do one more here with oxygen, the atomic number is 8. The mass number, protons plus neutrons, 8 plus 8 is 16. And charge is 0 again. 8 protons minus 8 electrons makes 0. Okay, so some good review there. Now, what about this case? This is still oxygen, but is my atomic number still the same? Yes, it's still 8, right? Is my mass number still the same? Still 8. But now, what is my charge? So for this one, charge is going to be protons, 8 minus the number of electrons, which is 10. So 8 minus 10 is negative 2. And so this is kind of leading us into our next example here. So if I have a charge that is different than 0, then we're going to call that an ion. And so an ion is basically just an atom that has a charge. That's all it is to it, okay? And let's get my picture. If I move the mouse too fast, the picture won't follow. And so we have two different types of ions. We have positive ions and we have negative ions, and we have special names for them. So a positive ion, we're going to call a cation. So a cation has a positive charge, which means that it lost an electron, okay? And my way to help you remember that is that cation has a T in it, C-A-T, and a T kind of looks like a plus, so cations are positive. Okay, and then an anion is negative, so that it has gained an electron. Remember, electrons are minus points, so if you gain an extra electron, you're going to have a negative charge. And the way to remember that one is that anion has an N in it, and so it is negative. And so now we can fill out the next spot on our little chart here. So we said a cation has a positive charge, and that means that it lost, well, I'll just say lost because it already says in the title there. So lost an electron. An anion then must have a negative charge, and that means that it would have gained an electron. Okay, so let's go back over here, and we've got a little bit more practice to do with that kind of thing. Okay, I'm going to move myself back over. I have to keep moving my little picture around to keep it out of the way. So we talked about charges and anions and cations. So I have another dumb joke for you. So cats have paws, and cations are positive. I know that's stupid, but maybe it'll help you remember, right? So cations are positive. Okay, so let's look at this one here. So a little more practice with everything. So fluorine, what is our atomic number? It's 9. I got 9 protons, right? What is my mass number? So mass number is protons plus neutrons. 9 plus 9 is 18. And what about the charge? So the charge for this one would be -1 because I have 9 protons and 10 electrons, and I subtract those. It's always protons minus electrons, so that'll give us -1. And so is it a cation or an anion? So since it has a negative charge, it's going to be an anion because anions are negative. Okay. What about this fluorine? So what is the atomic number? Still 9. Every time you have fluorine, the atomic number is going to be 9. Okay. What is the mass number? Well, I have more neutrons now, right? So 9 plus 10 would be 19 for my mass number. And my charge would be 9 minus 10 for 9 protons minus 10 electrons. And so I get -1. And that means that this is what kind of ion? Still an anion. Okay, good. So let's do another one. So here's potassium, which is K. What is the atomic number? Atomic number is 19. If we have 19 protons, we got an atomic number is 19. What is my mass number? Okay, so mass number, protons plus neutrons, 19 plus 20 would give me 39. Okay, and last of all, what is my charge? So charge, I'm going to take protons minus electrons, 19 minus 18, and I get +1 this time. Okay, so if it's positive, is it going to be a cation or an anion? So remember, cats have paws, or cation has a T in it, which kind of looks like a plus sign. So cations are, or this potassium is a cation. All right, what about barium, which is Ba? What's the atomic number? 56. Says so right there. 56 protons means the atomic number is 56. All right, what about the mass number? Protons plus neutrons. Okay, this one you might have to think a little bit more. 56 plus 80 is going to end up being 136 is our mass number. What about our charge? Protons minus electrons. So 56 protons minus 54 electrons, that's a difference of 2. So our charge is positive 2 because more protons than electrons. And so does that make this a cation or an anion? It's a cation. If it's positive, it's a cation. Okay? Good. So let's do one more. Aluminum, how many protons? I mean, what's the atomic number? 13. Yeah, the number of protons is the atomic number. Okay. What about what's the mass number? Okay, protons plus neutrons. 13 plus 14 is going to be 27 for my mass number. And what's the charge? Okay, protons minus electrons would be 13 minus 10 would give me a charge of plus 3. And so if it's positive, is this a cation or an anion? It's a cation because cations are positive, right? Okay, so moving on, let's talk about another vocab word here, isotope. So an isotope basically has the same number of protons, but a different number of neutrons. So it's the same element and the same atomic number because it has the same number of protons, but the difference here, it has a different mass number. So same element, different mass number. And so that should help us fill in the next little spot on our worksheet. We're almost done. So isotopes have the same number of protons, but they have a different number of neutrons. So they have the same atomic number, but different mass number. So make sure you fill that in like that. And we just have one more thing to talk about, so we are almost done with this. And let's look at our little slide here. Okay, so the last thing we're going to talk about is how we kind of put all this information together in a way that we can, make sense of it. And as soon as I get my picture out of the way, there we go. Okay, so atomic symbols or chemical symbols, as we will call them sometimes. Let's talk about what all we got here. So first thing is, the chemical symbol, we're going to have some kind of combination of letters that is going to be our chemical symbol. We'll do more practice with this soon, but for right now, you're always going to have at least either one or two letters, and the first one, or the only one, if there's only one, is always capitalized, okay? So in this example, I have a capital N and an A, which is actually for sodium. Next up, the atomic number. Didn't put myself in a very good spot, did I? There we go. Atomic number is going to be down to the bottom left, okay? So the atomic number for sodium is 11. It has 11 protons, so we got an 11 right there. Next up, the mass number goes at the top left, okay? So we could tell from this, what information we have so far, that we have 11 protons, and then if I do, 11 protons plus what would give me 23? That would be 12, right? So this has 12 neutrons, so you have to do a little bit of math there. Like I said, we'll get lots of practice with that coming up. And last of all, our charge is going to go to the top right. So knowing that this is a plus 1, or just a plus, usually if it's just 1, we don't write the number, we just write a little plus. So that means I have more protons than neutrons. So I have 11 minus something equals 1. So we know, okay, that's 10, right? So this would have 10 electrons. So we'll get some more practice with chemical symbols in the future. But for right now, what we need to do is fill in this last little graphic here on our worksheet. And so the way to do that is you click on it, click edit or double click it, whatever you want to do, and come in here. We're going to do the same thing we did before, text box. What do we call just the letters themselves? That's just our chemical symbol. Okay, and what do we call this number at the top left? That is our mass number. Here's another little trick too. The mass number will always, always, always be bigger than the atomic number because you can never have a negative number of neutrons, right? Okay, so then we need to make, all right, they're drilling next door. I'm going to try to finish this video though. So we need to make another text box for the little plus sign up there, which is telling me the charge. And then last of all, we are going to label this number at the bottom left, which we know is the atomic number. Okay, so put in all those labels, save and close. You got it labeled in your notebook now. The last thing I wanted to talk about, I'm just going to go through this kind of quickly, is ions and isotopes can be a little bit confusing because they both have I's and they deal with atoms and stuff, right? So let me just kind of give you a couple of examples of how they, so many distracting noises, but we're almost done here. So this is an example of carbon, right? Atomic number 6, mass number 12. If I don't have a charge up here, that means the charge is 0, okay? This is a carbon ion because it is still carbon, but it has a -4 charge, so this would be carbon anion. But I could also have a carbon isotope. So this, still carbon, still has 6 protons, but now it has a different mass number. Charge is still 0, right? So that's just a different isotope of carbon. This is also a different isotope of carbon, but it's also an ion, an anion, right? So same protons, different number of neutrons, so different mass number, different number of electrons, so it's an ion, so different charge, right? Now, so we've changed this number, the top left number, the mass number. We've changed the top right number, the charge. What happens if I change the bottom left number, the number of protons? Well, if I change the number of protons, that means we have a different element, okay? So if I have 7 protons, atomic number of 7, it's not carbon anymore. Now we've got nitrogen, okay? So nitrogen could have 7 protons, 7 neutrons for a mass number of 14, 7 electrons, so there's no charge. Or I could have a different, I could have a nitrogen ion, right? So you have ions and isotopes and different elements and all kinds of stuff. And like I said before, we're going to have lots and lots and lots of more practice with this stuff. This is kind of our introduction. So get ready for lots of more fun, right?